All right, so this is 8.2 day 1, which is vectors in the coordinate plane. So it says recall from section 8.1, which is notes prior to these ones, that a vector is written in the form v equals a times I plus b times j. A vector can also be written in the form, and then we can use this, looks like a less than sign, a comma b greater than sign. So this is called component form. Okay, so when you can write it like this, you can write it in component form, or you can do component form with I and j, which is what we have been doing. So component form would be a comma b, and then component form with I and j is v equals a times I plus b times j. All right, so we already talked about this a little bit in the 8.1 notes, but we talked about magnitude and unit vectors. So I went over how to find the magnitude based on the diagram. It forms a right triangle, so you use Pythagorean theorem, but you solve it for the hypotenuse. So the magnitude formula is that magnitude is equal to the square root of a squared plus b squared, and that's your formula right there. So let's try one of these. It says, given the vector v equals 2i minus 4j, where a is 2 and b is negative 4, find the magnitude. So to find the magnitude of v, we use the magnitude formula, which is the square root of a squared plus b squared. So I have the square root of 4 plus 16, which is the square root of 20. Now we want to write our answer in simplest radical form. So let's make sure we do that. There is a perfect square that goes in there. 4 goes in there 5 times. So we're going to say our magnitude is 2 root 5. And that's the length of the vector. All right, so to find the unit vector in direction of v, we use the equation u equals, and then we take the vector and we divide it by the magnitude. So it says find a unit vector in the same direction as this vector. So this isn't a unit vector because it doesn't have a length of 1, but I want to find the vector that has the same direction that's a unit long comparatively to that vector. So what you're going to do is you're going to take that vector and you're going to divide it by the magnitude. So first thing we need to do is find the magnitude. So we're going to do the square root of negative 5 squared plus 12 squared. Square root of 25 plus 144. It's the square root of 169, which is 13. So the magnitude is 13. You could also have realized that it is a 5, 12, 13 right triangle and just said it was 13. All right. All right, so now we're going to find the unit vector. To find the unit vector, we do u equals. You take the vector, which is negative 5i plus 12j, and you divide it by the magnitude, which is 13. And then you're going to divide each of the components by 13. So I'm going to divide this by 13 and divide this by 13. So I have u equals negative 5/13. If it was simplifiable, I would. I plus 12/13 j. And this is your unit vector with the same direction as that vector, but a length of 1. All right, so this is a u-try. You can go ahead and pause the video and try these. You should have gotten this vector has a length of 5. I can tell by looking at it that's a 3, 4, 5 triangle, but if you use the formula, move that down to show you, square root of negative 3 squared plus 4 squared is the square root of 9 plus 16, which is the square root of 25. And that's why the magnitude is 5. Now find the unit vector. So I'm going to do u equals. I'm going to take that vector, which is negative 3i plus 4 times j, and divide it by 5. Divide each of the components by 5, and I get u equals negative 3/5 I plus 4/5 j, and that's your unit vector with the same direction. Okay. All right, next it says we'll be writing a vector in terms of its magnitude and direction. So it says consider the vector v, which is a times I plus b times j. The horizontal component, which is a horizontal component, which is A, and the vertical component, which is B, can be expressed in terms of the magnitude, the length of V, and the angle theta that V makes with the positive x-axis going counterclockwise. This angle is called the direction angle. Of V, and it is shown in the figure to the left. Well, we have to draw it. All right, so let's draw a position vector, which starts at 0, 0, and then there'll be another point out here where it ends at, right? We're going to just use the first quadrant, and let's show the direction like so. Okay, so if this is the vector V equals AI plus B times J, this distance from here to here is A. And then this distance from here to here is B, because that's the point A comma B. The length is the magnitude of the vector V. And then the angle formed by the positive x-axis and the terminal side is theta, or by the positive x-axis and the vector is theta. All right, so that is what the direction angle is being shown right there. All right, so it says by the definition of sine and cosine, we know that the cosine of theta is equal to adjacent over hypotenuse. So if I do the adjacent side, which is A, over the hypotenuse, which is the magnitude of V, and then it says underneath it, or A is equal to, so basically it wants us to solve this equation for A. So if we solve this equation for A, I can put this over 1 and cross multiply to do that. And I get A equals the magnitude times the cosine of theta. So A is the same thing as the magnitude times the cosine of that angle. So if I know the magnitude and the cosine of that angle, I can get A. Sine, same idea, but obviously it's opposite over hypotenuse. So B over the magnitude. And if I put that over 1 and cross multiply, I get B equals the magnitude of the vector, the length of the vector, times the sine of that angle. So to get B, I can do the magnitude times the sine of the angle. So it says, notice you can use the magnitude and direction to write the vector. And that's what we're doing, magnitude, direction, magnitude, direction. All right, so writing a vector in terms of magnitude and direction, let B be a non-zero vector. If theta is the direction angle measured from the positive x-axis to V, then the vector can be expressed in terms of magnitude and direction angle as V equals, right, they used a capital here, so that's why I'm using capital V. And then instead of writing A times I, instead of writing A, we can write the magnitude of the vector times the cosine of theta, I, plus, and then instead of writing B times J, B is the same thing as the magnitude of the vector times the sine of theta times J. All right? So also what I want you to realize in these problems that we're about to do, the word problems, is that magnitude, when we're talking about magnitude, the length there, it is a lot of times in these problems, speed. Because what you'll be looking at is that your x-axis is time and your y-axis is distance. So you'll have like miles per hour. So it'll be like your speed. Okay, so these are non-calculator problems, and then I have calculator problems. So let's start with the non-calculator problems. If these are non-calculator problems, that means theta is going to be an angle that you know from the unit circle. If you get calculator problems, that means theta is not an angle that you know from the unit circle. All right, so a quarterback releases a football with a speed of 44 feet per second. So speed is another word for magnitude, right? So this is your magnitude. And an angle of 30 degrees, so that is theta. With the horizontal, angle of 30 degrees with the horizontal, so that is telling if it's theta. If it was at the vertical, then we would have to figure out what theta is. Express its velocity as a vector in terms of I and J. So we have V equals magnitude, which is 44, times the cosine of theta, which is 30, plus magnitude, which is 44, times the sine of 30 degrees, J. And I forgot my I right there. So let's squeeze that in. All right, so I need cosine of 30 and the sine of 30, so I need my ordered pair for 30 degrees. This is why it's no calculator. So 30 degrees, remember, is root 3 over 2, 1/2. So now I'm going to replace. So I have V equals 44 times root 3 over 2, I, plus 44 times 1/2, J. All right, so I have V equals 44 root 3 over 2, but realize I can simplify 44 over 2, so I'm going to do that right now. 44 over 2. 2 goes into itself once. 2 goes into 44 22 times. So this is 22 root 3I plus, and then half of 44 is 22J. And there's your vector. And that's why you don't need a calculator, is because you know the cosine of 30 and the sine of 30. All right, next one. The wind is blowing 20 miles per hour, so that's our magnitude, in the direction of north 30 degrees west. Express its velocity as a vector, v, in terms of I and j. So first off, I have to know where north 30 degrees west is, because I don't know if it actually is 30 degrees just by looking at it. So let's draw that. Never eat soggy Wheaties. All right, so north 30 degrees west. So from the north towards the west, 30 degrees. So that's this right here. All right, so theta is not 30 because theta starts at the positive x-axis, goes counterclockwise. So if this is 90 and that's 30, theta is 120 degrees. All right, so now I can write my equation. V equals the magnitude, which is 20, cosine of 120 degrees I, plus 20 magnitude, sine of 120 degrees J. All right, so I need the cosine and the sine of 120. So 120 degrees is in the second quadrant, as it is right there. It is a 60-degree reference angle, so that is 1/2 root 3 over 2. But since it's in the second quadrant, it's to the left and up, so that's negative. And now I'm going to replace. So I have V equals 20 times, instead of cosine of 120, I'm doing negative 1/2 I, plus 20 times, instead of doing sine of 120, I'm writing root 3 over 2 J. All right, simplify that. Negative, and then half of 20 is 10 I, plus, and then half of 20 is 10, so 10 root 3 J. And there's your vector. Okay, example 5 is a calculator problem, 5A and 5B. Round components to the nearest thousandth. So we're going to need our calculator for this, which is not a big deal. A plane is heading east and takes off from a runway at 150 miles per hour, magnitude, at an angle of 8 degrees with the runway. Write vector V in terms of I and J. So I have to draw what this looks like. So here's a runway. A plane is taking off. So there's my plane taking off. You see it? Ooh, look at how pretty it is. And it's making 8 degrees with the runway. So if that's the x and y axis, theta is 8 degrees. All right, so we have V equals magnitude, which is 150, cosine of 8 degrees I, plus 150 sine of 8 degrees J. So this is a calculator problem because I don't know what the sine of 8 degrees is. So I'm going to pull up my calculator. And I need to know what the cosine of 8 degrees is. And then I also need to multiply it by 150. So I'm going to put this whole thing in my calculator right here. That is 8 degrees. So first thing I'm going to do is check to make sure my calculator is in degree mode. Sure is. Sure is. Okay, so I'm going to do 150 cosine of 8 degrees. And it says round where? The nearest thousand. Good. 3 decimal places. V equals 148.540I. And now we need 150 plus sine of 8. So I'm going to put this in my calculator. I'm not going to put down the plus sign yet, just in case that's a negative number. No, it's not. It's positive. 150 sine of 8 degrees is, so positive, so plus 20.876 J. And the reason I knew it was positive because it's in the first quadrant where x and y are positive. And there's my vector. All right, one more. A plane with an airspeed of 150 miles per hour, magnitude, is flying in the direction of north 35 degrees west. Write a vector v in terms of I and j. So let's see what that direction angle is. Never eat soggy Wheaties. All right, north towards the west, 35 degrees. So about there-ish, 35 degrees. Theta is this angle right here, where this is 90. 90 plus 35 is 125. All right, so I have V equals 450 times the cosine of 125 degrees I plus 450 sine of 125 degrees J. So I have V equals, once again, I'm going to put this in my calculator to get a decimal. I'm going to put this in my calculator to get a decimal. All right, 450 cosine of 125. This should be negative because the x value is negative in the second quadrant. Negative 258.109I. And this should be positive because it's in the second quadrant and y's sine's positive in the second quadrant. 450 sine of 125. And I get 368.618J. All right, that's it